video series on broadband technologies. WiMAX Worldwide Interoperability for Microwave Access is a family of wireless broadband communication standards based on the IEEE 802.16 set of standards, which provide multiple physical layer PHY and media access control options. The name WiMAX was created by the WiMAX Forum, which was formed in June 2001 to promote conformity and interoperability of the standard, including the definition of predefined system profiles for commercial vendors. The forum describes WiMAX as a standards-based technologies enabling the delivery of last-mile wireless broadband access as an alternative to cable DSL. IEEE 802.16m or Wireless MAN Advanced was a candidate for the 4G in competition with the LTE Advanced standard. WiMAX was initially developed to provide 30 to 40 megabit per second data rates, with the 2011 update providing up to 1 gigabit per second for fixed stations. The latest version of WiMAX release 2.1, popularly branded as known as WiMAX 2 Plus, is a smooth, backwards compatible transition from previous WiMAX generations. It is compatible and interoperable with TD-LTE. WiMAX refers to interoperable implementations of the IEEE 802.16 family of wireless network standards ratified by the WiMAX Forum. Similarly, Wi-Fi refers to interoperable implementations of the IEEE 802.11 wireless LAN standards certified by the Wi-Fi Alliance. WiMAX Forum certification allows vendors to sell fixed or mobile products as WiMAX certified, thus ensuring a level of interoperability with other certified products as long as they fit the same profile. The original IEEE 802.16 standard, now called Fixed WiMAX, was published in 2001. WiMAX adopted some of its technology from Vibro, a service marketed in Korea. Mobile WiMAX, originally based on 802.16e 2005, is the revision that was deployed in many countries and is the basis for future revisions such as 802.16m 2011. WiMAX was sometimes referred to as Wi-Fi on steroids and can be used for a number of applications including broadband connections, cellular backhaul, hotspots. It is similar to long-range Wi-Fi, but it can enable usage at much greater distances. Mobile WiMAX was a replacement candidate for cellular phone technologies such as GSM and CDMA, or can be used as an overlay to increase capacity. Fixed WiMAX is also considered as a wireless backhaul technology for 2G, 3G, 4G networks in both developed and developing nations. In North America, backhaul for urban operations is typically provided via one or more copper wireline connections, whereas remote cellular operations are sometimes backhauled via satellite. In other regions, urban and rural backhaul is usually provided by microwave links. The exception to this is where the network is operated by an incumbent with ready access to the copper network. WiMAX has a more substantial backhaul bandwidth requirements than legacy cellular applications. Consequently, the use of wireless microwave backhaul is on the rise in North America, and existing microwave backhaul links in all regions are being upgraded. Capacities of between 34 megabits per second and 1 gigabit are routinely being deployed with latencies in the order of 1 millisecond. In many cases, operators are aggregating sites using wireless technology and then presenting traffic onto fibre networks where it's convenient. WiMAX in this application competes with microwave radio, E-line, and simple extension to the fibre network itself. WiMAX directly supports the technologies that make triple play service offerings possible, such as quality of service and multicasting. These are inherent to the WiMAX standard rather than being added on as carrier Ethernet is to Ethernet. On May 7, 2008 in the United States, Sprint, Nextel, Google, Intel, Comcast, Bright House and Time Warner announced a pooling of an average of 120 megahertz of spectrum and merged with Clearwire to market the service. The new company hoped to benefit from combined services offerings and network resources as a springboard past its competitors. The cable companies were expected to provide media services to other partners while gaining access to the wireless network as a mobile virtual network operator to provide triple play services. Some wireless industry analysts such as Ken Delaney and Todd Cork at Gartner were skeptical how the deal would work out, although fixed mobile convergence had been a recognized factor in the industry. Prior attempts to form partnerships among wireless and cable companies had generally failed to lead to significant benefits for the participants. Other analysts at IDC favored the deal, pointing out that as wireless progressed to higher bandwidth, it inevitability competes more directly with cable, DSL, and fibre, inspiring competitors into collaboration. Also, as wireless broadband networks grew denser and usage habits shift, the need for increased backhaul and media services accelerated. Therefore, the opportunity to leverage high bandwidth assets was expected to increase. Fibre broadband is a new type of broadband that is currently being deployed in the UK by BT, Virgin Media and other operators which use fibre optic cables to help increase the speed of your broadband connection. It is often referred to as super fast broadband or next generation broadband as it offers faster speeds than have been available to date using older generation networks. It is available to both home and business users. There are generally two types of fibre broadband connections. Fibre to the cabinet (FTTC) involves running fibre optic cables from the telephone exchange or distribution point to the street cabinets, which then connect to a standard phone line to provide broadband. This is combined with a copper cable from the cabinet to the home or business, which uses VDSL or similar technology that can deliver much faster speeds over shorter distances. So you can see here in this picture, this is an example of fiber to the cabinet. Here you can see the telephone exchange and the cabinet, and here's a fiber optic cable. And from the cabinet to the premises is a copper cable. Fiber to the home. Fiber to the premises (FTTP), also often referred to as fiber to the home (FTTH), provides an end-to-end fiber optic connection the full distance from the exchange to the building and can deliver faster speeds than FTTC as there is no copper leg at all. So you can see in this example here, you have the telephone exchange, and here are like distribution aggregation nodes, and you can see here full fiber optic cable to the premises. So this is obviously faster than fiber to the cabinet. Fiber to the cabinet (FTTC) broadband comes in three main variants, which offer a downstream line connection speed of 80 megabits per second, 55 megabits per second, or 40 megabits per second, but an actual maximum throughput speed service will be slightly lower than this at around 76, 52, and 38 megabits per second. different upstream speeds are available at either 2 or 10 on the 40 megabits variant, with 10 megabits per second on the 55 megabits per second version, and finally 20 megabits per second on the 80 megabits per second. Not everyone will receive the maximum speed, as it depends on the length of your phone line to the cabinet, which is providing your broadband service. It should be noted that since all the FTTC services rely on the same VDSL2 technology, that unless you're getting maximum speed from a 40 megabits per second product, upgrade to a 55 or 80 megabits per second product will not boost your speeds. If you are lucky enough to live in an area that will receive fibre to the premises, FTTP full fibre, download speeds of 330 megabits per second and upstream speeds of 30 megabits per second are available. The FTTP products offer the same speed options as on FTTC at the same price, and also faster versions at 100 megabits per second down, 15 meg up, 115 megabit, 130 megabit, 330, 320 meg, and 330 and 30 meg. Further speed upgrades to full fibre to 1 gigabit per second, 1000 megabits, are expected to be on sale later in 2017. The massive advantage FTTP has is that the connection speed is not affected by distance. So here's just an old picture of how ADSL works. Here you have the telephone exchange, and here you see the copper wire. So the further you are from the telephone exchange on the old ADSL, the slower the connection will be. And this is a picture of how cable broadband works. This could be the head end and probably fiber optic cable. And here then you have coax cable. So this is how the network looks. And this then is how satellite broadband works. Here you see the transmitter and the receiver. And this is the broadband service provider end, and it bounces a signal here off a satellite. And this is a mobile phone mast, which is 4G LTE. So this is how mobile broadband will work. So everyone, I hope you enjoyed this video series. Please like and subscribe, and thanks for watching.